Welcome to this video. This video we will look at how we can manage and interact with the cluster using declarative and imperative approach. Before we are going to start, we need a Google Cloud subscription and a GKE standard cluster. First we will try with the imperative approach, then we will do with the declarative approach. When we work with the Kubernetes, there are two primary approaches to manage and interacting with the cluster. One is declarative approach and another one is imperative approach. The declarative approach focuses on describing the desired state of the Kubernetes resource and letting Kubernetes handle the implementation details. In this approach, we use YAML or JSON files called manifest to define the desired state of objects such as pod, service, deployments. We specify the configuration parameters, properties, and relationship for this object in the manifest file. Then we use the kubectl apply command to apply the manifest to the cluster, and Kubernetes will reconcile the current state with the desired state. Advantages of the declarative approach. Kubernetes ensures that the desired state is maintained regardless of the current state of the cluster. Next, version control. Manifest file can be stored in a version control system, allow you to track changes and easily roll back if needed. Scalability. Declarative configuration make it easy to manage and scale complex application and infrastructure. Next approach is imperative approach. In this approach, interacting with the Kubernetes through direct commands using kubectl tool. Instead of describing the desired state, you provide explicit instruction to create, modify, or delete resource. For example, we can use commands like kubectl run to create a new deployment or kubectl delete to remove a resource. Advantages of imperative approach. Quick iterations. The imperative approach can be useful for rapid prototyping or quick changes to resource without the need to define a complete manifest. Interactive troubleshooting. You can use imperative command to inspect and diagnose the current state of the resource or the cluster itself. Imperative approach can be handy for certain scenarios. The declarative approach is generally recommended for managing Kubernetes resource in a production environment. It provides a more consistent and reproducible way of managing and maintaining the desired state of your application and infrastructure. We will start with the imperative approach. Go to command prompt, kubectl get nodes. This command is used to retrieve the list of nodes in your Kubernetes cluster. When you run this command, you will see a table with the information about each node, including its name, status, role, age, and version. We will check the same in Web Console as well. Under the Nodes tab, you can see the same nodes. kubectl get nodes -o void. This command is used to retrieve the detailed information about the nodes in your Kubernetes cluster, including additional details such as internal IP address, external IP address, and the node's host name. You can see the additional informations like internal IP, external IP, OS image, kernel version, and container runtime. This command provides a more comprehensive view of the nodes in your cluster, including their networking details and runtime environment. To get detailed information about a specific node in Kubernetes, you can use the kubectl describe node name. When you run this command, you will see extensive information about the specific node, including its status, address, capacity, utilization, condition, and more. The output will include details like node condition, capacity, and allocatable resource, node address, and attached Kubernetes labels. The output of the kubectl describe node command provides valuable insight into the node's configuration, health, and variable resources. It is especially useful for troubleshooting or understanding the state of a specific node in your cluster. Kubectl get pods. This command is used to retrieve the list of pods running in a specific namespace. When you run this command, you will see a table with the information about each pod, including its name, status, age, and other relevant details. Right now, we don't have any pod created inside our cluster. First, we will create a pod. kubectl run. This command is used to create a new pod. kubectl run web API pod, that is pod name. Then we need to specify Docker image path. I have already created a image and pushed into Docker Hub. We are going to use this image. If you want to know more about container registry, I recommend you to watch this video. Container registry and Azure DevOps. In this video, I am explaining how we can build and push images into different types of container registries like Docker Hub, Azure Container Registry, Elastic Container Registry, and Artifact Registry. I will provide the link in description box. Now our pod is created. kubectl get pods. Now you can see one row is listed with named as Web API pod. You can also use short form kubectl get PO. To describe a specific pod in a Kubernetes, you can use kubectl describe pod command. kubectl describe pod and pod name. This command will provide detailed information about the specific pod, including its status, containers, event, and various other details. The output will contain information about the pod state, condition, volume, IP address, and any event associated with the pod. This command is useful for troubleshooting and understanding the state of a specific pod. It can help you identify issues, check resource allocation, and gather information about the pod's configuration. In the last session, you can see events. First it's scheduled, then it's pulled image from container registry, then it's created container. After that, container started. kubectl logs. This command is used to retrieve the logs of a specific pod in Kubernetes. By running kubectl logs pod name, you can view the logs of the containers running within that pod. kubectl expose. This command in Kubernetes is used to create a service that exposes a set of pods to network traffic. It allows other pods or external users to access the pod within a cluster. The basic syntax is kubectl expose, resource type, resource name, pod, target pod, name, and service type. Resource type. The type of resource you want to expose. It can be deployment, replica set, or pod. Resource name. The name of the resource you want to expose. Port. The port number on which the service should listen for incoming traffic. Target port. The port number on the ports to which the incoming traffic should be forwarded. Name. The name you want to assign to the service. Service type. The type of a service you want to create, such as cluster IP, node port, load balancer, or external name. Cluster IP. This is the default service type. It creates an internal IP address that allows communication within the cluster. The service is only accessible from within the cluster and not from outside. Node port. This type expose the service on a static port on each selected node. It opens a port on every node's IP address, and incoming traffic to that port is forwarded to the service. The service is accessible from outside the cluster using node IP node port. Load balancer. This type provisions an external load balancer in a cloud environment to distribute traffic to the service. It obtains an external IP address or a DNS name that client can use to access the service. External name. This type creates a service that acts as an alias to an external service outside the cluster. It does not have a selector or endpoints and simply returns a CNAME record that provide the external name. We will try to create a service using load balancer type. Go to command prompt, kubectl, expose, port name, type, load balancer, then port, name, web API service. Now service is exposed. We will list the service, kubectl get service. You can see new service is created and the external IP is pending. It will take few seconds to generate the external IP. We can also use the short form kubectl get svc. Still it's pending. We'll try once again. Now external IP is created. We will try to access using this IP. Go to browser, copy. We need to provide API URL as well. Now application is up and running. It's returning the values. If you want to get more information on service, you can use kubectl describe command. Kubectl describe svc service name. You can see the details of the service and you can see the events as well. Next we will try to delete the service and port. Kubectl delete service name. This command is used to delete a service. Now service has been deleted. We will try to list the services. Kubectl get svc. You can see the load balancer service is deleted. Next we will try to delete ports. Kubectl delete port name. Now port has been deleted. We will try to list the port. Kubectl get po. You can see no resource found in default namespace. Declarative approach. In this approach, YAML files are used in Kubernetes to define the desired state of various resources within the cluster. First, we will check the basics of YAML file. YAML is a human-readable data serialization format commonly used for configuration files and data exchange. It is used in Kubernetes to define the desired state of resource using YAML manifest. Structure. YAML uses indentation to define structure and hierarchy. Nested elements are indented with space or tabs. Spaces are recommended 2 or 4 spaces per level. Hierarchical relationships are represented by indentation levels. Comments. Comments in YAML start with the hash symbol and continue until the end of the line. Comments are used for providing explanations or annotation in the YAML file and are ignored by YAML parser. Key value pairs. Key value pairs are represented using a colon to separate the key and value. The key and value are separated by a space. String. YAML support different types of strings including plain string, single quoted string, double quoted string. Plain strings are unquoted and can contain alphanumeric character, hyphen, underscore and certain special characters. Single quote strings preserve the exact characters and do not support escape sequences. Double quote string support escape sequences and can include variable or expressions. List. Lists are represented using a hyphen followed by a space to indicate individual items in the list. List can contain any combination of values including other lists or key value pairs. Nested structure. YAML support nesting of list and key value pairs to create complex data structures. Indentation is used to represent the nesting. These are the basic concepts of YAML that will help you get started with writing YAML files for various purposes, including Kubernetes manifests. We need to make sure proper indentation and structure. This is the example of YAML. We will try to create a YAML file for pod creation. Create new YAML file pod.YAML API version v1. This will specify the API version of the Kubernetes object being created. Kind pod. This indicates that the Kubernetes object being defined is a pod. Metadata. This contains metadata information about the pod. Name mypod YAML specifies the name of the pod as mypod YAML. Labels. Define the labels of the pod, which can be used for identification or grouping purpose. In this case, the label app is set to the myapp YAML. Spec. It describes the desired state of the pod. Containers. Contain a list of the containers running within the pod. Name my container specifies the name of the container as my container. Image defines the container image to be used, in this case Paranode/Core Web API with version v1. Ports specifies the port that the container should listen on. Container port 80. Set the container port to 80. Indicate that container will be listening on the port 80 for incoming traffic. Overall, this YAML code defines a pod named mypod YAML with a single container named mycontainer. The container uses the Sparrow Node/Core Web API v1 image and expose the port 80 for incoming connection. The pod is also labeled with app myapp YAML for identification or grouping purpose. We will add a comment section as well. pod YAML. In Kubernetes YAML file, you can see 4 main sections: API version, kind, metadata, and spec. API version. This field specifies the version of the Kubernetes API that should be used to interpret the YAML configuration. It ensures compatibility between the YAML file and the Kubernetes cluster. Kind. The kind field indicates the type of the Kubernetes resource being defined in the YAML. It specifies the object's kind or category. For example, pod, deployment, service, config map, etc. Metadata. The metadata section contains information about the Kubernetes resource being defined. It includes fields like name, labels, annotation, and more. The metadata section helps identify and organize the resource within the Kubernetes cluster. Spec. The spec section describes the desired state of the Kubernetes resource. It defines the configuration and characteristics of the resource, such as the container to run, volume to mount, network settings, and other specifications specifies the resource type. The spec section defines the operational behavior of the resource. These 4 elements are commonly used in Kubernetes YAML definitions to specify the type of resource, provide metadata about the resource, and define its desired state and configuration. kubectl apply. This command is used to create or update Kubernetes resource based on the configuration defined in a YAML file. This allows us to apply changes to our cluster by declaratively specifying the desired state of the resource. kubectl apply -f file name pod.yaml. Now pod is created. We will list the pods. kubectl get po. You can see the newly created pod. kubectl delete command is used to delete the resource. kubectl delete -f YAML file name pod.YAML. Now pod is deleted. We will list the pod kubectl get PO. You can see the no resource found in the default namespace. We will add one more YAML file for creating service, service.YAML. API version v1, kind service, then metadata, name my service. Then we need to specify the spec, type load balancer, selector app my app YAML. Next we need to provide the ports, protocol TCP, port 80, target port 80. This YAML file defines a service named my service with the type set to load balancer. The service selects ports based on the label app my app YAML and forward the incoming traffic on the port 80 to target port 80 on the selected ports. This configuration allows the service to expose the port externally using a load balancer. We will apply the changes. First we will apply pod kubectl apply pod YAML. Pod is created. Next we will apply service.YAML. Service is created. We will try to list ports kubectl get PO. Also we will list service kubectl get SVC. You can see the new service is created with the load balancer. External IP is pending. We will try to once again. Now external IP is generated. We will try to access the application using this IP. Go to browser, IP address and URL. Application is up and running. Now we are using two different files for pod and service. We can combine both files into a single file and separate by using 3 hyphens. First we will delete both the service and pod. Add new YAML file named as pod and service.YAML. Copy the content from pod.YAML file. Paste the content. We need to add a document separator 3 hyphen. We will add a comment. Copy the content from service.YAML file. Copy, paste. Now we merged both the files into a single file. kubectl apply -f file name pod and service.YAML. Some network issue. We will try once again. Now pod and service has been created. External IP is not created yet. We will list once again. Now external IP is created. We will try to access the application. Application is up and running. We will try to delete kubectl delete -f YAML file pod and service.YAML. Now pod and service has been deleted. Next we will check how we can add environment variable in pod. I have already enabled Swagger in Web API project. It will work based on environment variable. Under the containers, we need to add environment variable env. We need to specify the name ASP.NET Core _ environment, then value development. We will save and apply the file kubectl apply -f file name. Now pod and service created. We will check the service. External IP is created. We will access the application. Paste the IP /swagger. Swagger is loaded based on environment variable. We will delete service and pod. kubectl delete -f pod and service YAML. Pod and services are deleted successfully. In this session, we tried with both the imperative and declarative approach. I hope everyone understood this session. If you have any question, please put them in the comment section below. Thanks for watching.